The next thing that we come to in Chapter 1 as far as introducing you to different concepts in geometry that you're going to be faced with throughout the year are angles. An angle is a geometric object formed by two rays sharing the same endpoint. Earlier in the chapter we talked about what a ray was. Here we can see that you have a ray AC and a ray AB, and they both have the endpoint A, and they form an angle. Now that angle has two different sides. The sides are the rays themselves. That's why AC is labeled side, AB is labeled side. There's also something called the vertex. The vertex is the central point of the angle formed by the endpoint of the two rays. Here we have the vertex, and it's point A. Point A is the vertex. We could label this angle CAB or BAC. Just like a line or a ray, we could label it left to right or right to left. CAB or BAC. And you can see the funny little angle symbols that are used in front of them. And we already identified the two rays that form it. Let's talk about classifying angles. There are four different ways to classify an angle. Once you know what an angle is, now let's talk about classifying it. We could have an acute angle. Actually, let's talk about this. There are two different ways to classify it. Okay? By its angles and by its type. And we're going to talk about that one later. Right now we're talking about labeling it by, or classifying it by its angles. An acute angle is an angle whose measure is less than 90 degrees. For example, the blue angle here, labeled ABC, is an acute angle because its angle is less than 90 degrees. Now, I don't know how many kids have a hard time measuring angles because they don't understand how to read the protractor. They don't know how to measure it because they're not sure how to work with the tool they're using. If I gave you a hammer, you could figure it out pretty quickly how to use it. If I gave you an axe, you could figure it out pretty quickly how to use it. A protractor is no different. Look at the way your angle is opened. It's opened this direction. So we're going to use a counting method, going from the bottom to the top. Now when you count, do you count from 2 billion down, or do you start at 0 and work your way up? Most people start at 0 and work their way up. So we're going to start at 0, and we're going to count 10, 20, 30, 40, 50, 60. Oh look, it's at 60 degrees. I don't know how many kids say, oh, it's 120 degrees. Really? We're starting at 180 and counting down? Or are we starting at 0 and counting up? You might say, well, then what's with the whole double numbering system? Sometimes you have angles that open from left to right. This one is opened right to left. Well, if it's pointed over here, I need to be able to measure it over here. And so I could still count from 0, but if I look, I'm counting from 0 and it's going all the way up to 180. Just like on the bottom, like my blue angle, is starting at 0 and it's counting up. Now, you're going to come across different angles and you're going to have to practice measuring them later, but let's go back to just classifying them. The other type is obtuse. An obtuse angle is an angle that's greater than 90. And here we have this angle that is greater than 90. Again, it is opening to the right, it's faced to the right, so we count using the right numbering system. Not counting down, but counting up. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. Oh look, that angle is 150 degrees. Count from right to left. This angle is not 30 degrees. That 30 would be talking about if an angle was over here and it opened like that. That angle would be 30 degrees. The one you're working with, the red one, is 150 degrees. Let's get that out of there so it doesn't confuse you. Then there's an angle called a right angle. And a right angle is exactly 90 degrees. If it opens to the left, if it opens to the right, it points at the 90 degrees, and it's right there, perfectly. Straight up and down, perpendicular. There's also something called a straight angle. And a straight angle is a weird way of saying it's 180 degrees. It is a straight line. I don't know why they just don't call it a straight line, but they call it a straight angle. Those 4 different types are very, very important right now. Acute, obtuse, right, and straight. The further we go into geometry, the more you're going to have to use those. You will never stop using those. Just because we leave chapter 1 doesn't mean you're going to get to forget those. You use all of geometry all the time. We use the segment addition postulate. Pretty soon, in a couple seconds, you're going to learn the angle addition postulate. It's still addition, it's still the same concept, but instead of adding segments, we're going to be adding angles. First, let's go through and let's label some of these angles. It says, example 1 says, identify all angles formed in the diagram, then classify them based on their angle measure. The first thing I want you to do is, let's just go from right to left. And the first angle that we come across, wow, that's horrible. Try and draw a straight line, Mr. Gentry. Let's try that one more time. Is that one. And we're going to label that angle JFK. Not the president, but the angle, JFK. You could also label it KFJ if you want, I don't care. But now let's actually classify it by its angles. Based on it opening to the right, we count to the right. 10, 20, 30, 40, 55. It's 55 degrees. And so if I go back, which one of these would a 55-degree angle fit in? Would it be a straight angle where it's 180 degrees? Would it be a right angle where it's exactly 90 degrees? Would it be an obtuse angle where it's more than 90? Or would it be an acute where it's less than 90? And I have a feeling the majority of you said that's acute because it's less than 90. Let's go to the next one. The next angle that we come across is JFL. Angle, whoops, sorry. Is angle JFL. And using the protractor, what do you think the degree is of that angle? Hopefully you identified it as 90 degrees. Now, if we go back, which one of these is exactly 90 degrees? Is it the acute that's less? Is it the obtuse that's more than 90? The right angle. Measure of angle is equal to 90. Well, that's what we have. So we have a right angle. Now you'll see me abbreviate it RT. You might even see the book label it RT. It's just a shorter way of labeling it. That way I don't have to write out RIGHT. And you'll see my little angle measure. The book might just use that. You'll even see it in our notes. That's angle. It's not less than, it's angle. The next one, the next angle that we come across, looks like this. And we can label that one angle JFH. Now we're still opening from right to left. So what's the angle measure? Well, just like we counted on JFK and JFL, let's count. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 145. So, what would you label an angle that is 145 degrees? Would you label it acute, where it's less than 90, or obtuse, where it's more than 90? Yes, you would. That is an obtuse angle. And then the last one that we come across is that one. Now, process of elimination, the ability to say, oh, it's 180 degrees. You know that angle JFG should be a straight angle. Please, 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 please be able to use a protractor. Now, we're going to work on it later in the year. But right now, here's your first introduction. Figure out how it opens. Does it open right to left or left to right? Then, identify its counting. You always count up. You never count down. It would make no sense to have a small angle like this be 165 degrees. That would make no sense. So, make sure that you're using the right counting method. There is something called the angle addition postulate, like what we talked about. Now, you've learned the segment addition postulate, where if this segment to this segment plus this segment to this segment equals the big segment, it's the same thing with an angle. If I take RSP plus PST, I get RST. Okay? This angle plus this angle gives us the larger angle. Just like, let me go back in our notes. Just like we used algebra and the segment addition postulate to solve for missing pieces, we're going to use the angle addition postulate and algebra to solve for missing pieces. For example, let's look at example 2. If LKN equals 145 degrees, find the measure of the two smaller angles. Well, the first thing that I want to do is I want to write a mathematical statement that tells me what angles add up to what. I know that angle LKN is made up of this angle, angle LKM, plus this angle, or angle MKN. And now I'm going to replace the information with what I know. I know, or they told me, that LKN is 145. So I'm going to replace it with 145 degrees. They also showed me over here that LKM is 2x plus 10. So I'm going to cross off LKM and in its place write 2x plus 10. I also see that MKN is 4x plus 3, so I'm going to replace it with 4x plus 3. Now I can use algebra here to solve for x and get x equals. Now that's great in algebra. In algebra, once you got the x, you were done. Or once you got the variable equals, you were done. But in geometry, you're only halfway done. In geometry, once you have the variable, you have to plug it in and find out what you're dealing with. In geometry, we're dealing with angles. If I don't know what those angles equal, then it doesn't matter what the x is. I have to use the x to find out what the angles equal. So let's solve this using algebra. The first thing I see is I have 2x and 4x. Well, I'm going to combine those and get 6x. I also see I have a positive 10 and a negative 3. Well, 10 minus 3 is 7. that still all equals 145. Excuse me. My pen is a little bit fidgety. Now I'm still going to try and solve for x because I need it to find out what the angles equal. So the first thing I'm going to do is subtract 7. When I do that, I get 6x equals 145 minus 7 is 138. Now I've got 6x equals 138. I don't want 6x, I just want x. This means multiplication, 6 times x. How do you undo multiplication? You use division. So 6 divided by 6 just gives me x. 138 divided by 6, well, let me grab my calculator. 138 divided by 6, it should be 23. Boom, 23. Well, now that's great, but I'm only halfway done. I know that angle LKM and angle MKN should equal 145, but I also know that LKM is 2x plus 10. 2x plus 10, and MKN is 4x minus 3. I'm going to find out what both of these angles equal. Replacing the x with what I found. So I'm going to replace the x with 23 because that's what I found it to equal. X equals 23. Come back up here. 2 times 23 is 46. 46 plus 10 is 56. I found angle LKM to be 56 degrees. Now, I've got 4 times 23 minus 3. Well, 4 times 23 is 92 minus 3. 92 minus 3 is 89. So I found MKN to equal 89 degrees. Again, it is awesome that I got x equals. That's fabulous. Because that shows me that I understand the angle addition postulate. That means that I understand that this angle plus this angle equals this angle. So angle LKM plus MKN equals LKN. And again, I know that these are a lot of different letters and you're getting confused. You have to pay attention. If you're not paying attention and you just hope, well, I'll pick it up when he does the examples, you're going to be lost. Make sure you're following and paying attention. When you set your angles to add up using the angle addition postulate, then we replace them. We took out LKM and put in 2x plus 10. Why? Because that's what they told me LKM equaled. It's 2x plus 10. Then we replaced MKN with 4x minus 3 because that's what it equaled. Then that allowed me to write my algebra equation. 145, because that's what LKN equaled, equals 2x plus 10 plus 4x minus 3. I use algebra to solve for x, and I get 23. Although that's fabulous, and I'm really proud of myself, I'm not done. Now I have to go through and say, okay, if x equals 23, then angle LKM, and then I plug in x, find out, MKN, plug in x, find out. That allows me to find what my individual angles equal. And that is geometry. This part is algebra. This part is algebra. You cannot get to the geometry without using algebra. Make sure that your algebra skills are where they need to be. There's also something called an angle bisector. Now, we dealt with a segment bisector. Okay, so you should know what a segment bisector is. It bisects a segment into 2 equal halves. The same could be said about an angle bisector. It bisects an angle into 2 equal halves. For example, if I have this drawing right here, and I'm given that this angle is 30 degrees, and this angle is 30 degrees, is ray AB an angle bisector? Does it cut this larger angle right? Does it cut this larger angle into 2 equal halves? And the answer is yes. They both equal 30 degrees. And you'll use an angle bisector, and again, just like if you have those little tick marks over a line segment, let me draw it. If I gave you these 2 little red tick marks, not black, but red, 1 red tick mark, 2 red tick marks, that would tell you that those 2 segments are equal. The same thing could be said about an angle. If you have 2 little red tick marks over in an angle, that's telling you that they're equal. So set them equal to each other. Let's practice a few more. Using the angle addition postulate, let's solve for x. We're not going to worry about what the 2 angles equal right now, not yet anyway, but let's just solve for x for this problem. The first thing I'm going to do is I'm going to write a mathematical statement. I'm going to say that angle KLM is made up of, or it equals, KLN plus NLM. Now this is not as complicated as what we all make it to be. This is like saying a cake is made up of batter and eggs. Or a cookie, a chocolate chip cookie, is made up of chocolate chips and cookie. Really not that hard. The big angle is made up of the 2 smaller angles. Now we can go through and replace everything with what they've told us. They told me that KLM is 180 degrees. They told me that KLN is 10x minus 5, and that NLM is 4x plus 3. Now I'm going to use my algebra skills to find out what x equals, because that's what I would use to plug in back here and find out what those 2 angles equal. So let's use our algebra. I can see right away that I have a 10x and a positive 4x. So I'm going to combine those to get 14x. I also see that I have minus 5 and positive 3. A minus 5 and a positive 3 gives me a negative 2. Now, the only way to get x by itself here is to get rid of the 14 and the negative 2. The 14 I'm going to save. That's going to be my last step. The first thing I want to do is get rid of this 2. So I'm going to add 2 to both sides. You might say, well, why? Because the only way to get rid of a negative is to add a positive, and they'll cancel each other out. I drop down what I didn't use, like 14x. 180 plus 2 is 182, and that wasn't too bad. And so now I've got 182 equals 14x. If I divide both sides by 14, that'll cancel out my 14, and I'm left with x equals 182 over 14. Well, I'm going to grab my calculator, or calculator, depending on where you're from. 182 divided by 14 gives me 13. So, x equals 13. Now, I know that that's a lot of work. In fact, we're not even going to worry about this guy right now. Okay? You can do this problem if you want more practice. You set it up the exact same. This angle plus this angle equals this angle. Okay? So you could do this problem if you want more practice. But to be honest, if you can do this problem that we just did, then you understand the angle addition postulate, and your algebra is where it needs to be. The first thing we did was we set up just a geometric statement saying the big angle, KLM, equals the two smaller angles. Then we replaced it with what they told us. They tell me that KLM is 180 degrees, so I write down 180 degrees instead of writing KLM. Or I replace it, I substitute it. Then they tell me that KLN is 10x minus 5. So I replace or substitute 10x minus 5 for KLN. Then they tell me NLM is 4x plus 3. So I substitute that in. Then I use my algebra to combine like terms. The 10x and 4x give me 14x. The negative 5 plus 3 gives me negative 2. And it still equals 180. Then I use my algebra skills to get 14x by itself by adding 2 to both sides. Then I divide by 14 because I need that 14 gone. The only way to get rid of a multiplication problem is to divide. So if I divide both sides by 14, I get x equals, and then 182 divided by 14 gives me 13, and that allowed me to solve it. Now I still need to substitute it back in for my angles to find out what angle KLN equals and to find out what angle NLM equals. That's something you can do on your own. If you can do these steps that we just did together using the angle addition postulate, then you're well on your way to doing very good in this class. If not, I really encourage you to write this problem down. We'll call it number 2. Number 2. I encourage you to write that problem down and to practice it. And then you can bring it to me and I'll tell you whether or not you did it correctly. I'll just tell you right now, if you do this problem, you should get x to equal 29. And so that'll tell you whether or not you did it correctly if you want it for more practice. Otherwise, we can just move on to our homework for tonight.